Hi, thank you. Really excited to be here and talk about reclaimed water and water quality and some research from a master's student who was with me last year, Dylan Barr. Dylan has since graduated and has a great job in Southwest Florida, but I'm going to present some highlights from his research today. So this morning in our keynote address, we heard someone talk about irrigation water flowing down the streets, right? And then Michelle Atkinson later on this morning talked about the nitrogen content of reclaimed water. So my talk is like those two talks got married and had a baby. That's what I'm talking about because we were working on irrigation overspray when lawns are irrigated with reclaimed water, and by overspray we mean just that irrigation water that's flowing down the streets when people are irrigating. When we talk about this in extension, we say hashtag just wet your plants or hashtag streets don't grow, because there's no need to irrigate the streets and the sidewalks and the parking lots and all of those things, but we all see it. And we also know that if that water is reclaimed water or former domestic treated wastewater, it's going to have elevated nitrogen and phosphorus compared to potable water. So what are the water quality impacts of that high nitrogen and phosphorus water flowing down the streets when people irrigate? All right, so the two major questions of this research were what amount of reclaimed water landscape irrigation is applied improperly as overspray? So just how much does that flowing down the street occur? And what is the nitrogen load amount of that overspray volume of water? In other words, how much nitrogen is flowing down the streets because of this process? And to answer this question, one of the first things that Dylan did was he used drone imagery of overspray. So you can see some examples of overspray in these pictures. And Dylan flew a drone a couple hundred feet above overspray images like this. And then we put it into some imaging processing software that converted those pictures into an area on the ground. So that was the first step. We had area on the ground that was receiving that overspray water. Right, so now we've got area. And then within that area, he did a bunch of repetitions of this. We went out over a couple of months. We went to several neighborhoods. We were primarily located in Martin and St. Lucie counties on the eastern part of the state. That's just where we were located. We were funded by South Florida Water Management District, so that's why we were over there. But we went into residential areas over the course of a couple of days every month and did a bunch of these tests where Dylan was simultaneously using his drone to capture area images and putting out catch cans like these that you see here when people were running their sprinklers and capturing that water on the streets and the sidewalks and places like that, the non-target areas. And in those catch cans, we can get depth of water, like an inch or 2 inches, whatever it is. So now we've had area that's being oversprayed, and we have the depth of that water, and we can take area and depth and convert that to a volume of water. So that's exactly what we did. We had a volume of water, and then for all of these tests that we did, we also collected a sample of that irrigation water and analyzed it for nitrogen, phosphorus, and carbon. And I'm only presenting data today for nitrogen, but we had phosphorus and carbon as well. So now that we have an irrigation volume that's being applied as overspray, and we know the nitrogen concentration of that, we can get the nutrient load, or in other words, pounds of nitrogen associated with that process of irrigation overspray. All right, so the data that we're going to show next is those pounds of nitrogen in the South Florida Water Management District based on some calculations and some assumptions that we made. Oh, first of all, just results of just how much do people overspray? From our test that we did, this is an average. We estimate that average overspray is about 34%. So in other words, when people are irrigating their lawns, and we use a lot of assumptions here, assumptions of like, assuming a lawn of a certain size and irrigating for a certain time based on IFAS recommendations. So in reality, people are probably irrigating much more than that because they probably do more than IFAS recommendations. But based on that, we feel like that overspray is about 34% of all the water that's being applied to lawns. So keep that in mind, 34%. And then this is what it converts to when we do that calculation to get pounds of nitrogen. that's associated with this overspray on a yearly basis. This would be data for the entire South Florida Water Management District based on the fact they have over 160,000 homes that irrigate with reclaimed water, and depending on which where they get their water from, and you can see those numbers, how astronomically huge they are. And I'm out of time, but lots of thousands of pounds of nitrogen associated with overspray. All right, so I'm out of time.